Hey there, Year 9's Mr. Herman here, and this is the third video installment on the tutorials for the worksheets. Unfortunately, I have to start this recording again. I did have the recording, but my computer notified me that I ran out of space. So I had to frantically start deleting stuff, a lot of videos that I've recorded from my computer, but that's okay. We can start again, but yeah, it might be a bit fast. So the first worksheet looks like this. Second worksheet, or part of the worksheet anyways, looks like this here, and the third one looks like this. These worksheets were either given Wednesday or Thursday, I don't remember off the top of my head. I'm going to just go through a couple of examples so you understand the processes that are being applied in order to solve for these set questions. So this one here, the first one, simplify the following expressions and match the corresponding letter to the correct answer below. Now, when we do simplify, you'll notice that a lot of these, or if anything, all the solutions don't have negative powers. So if we end up getting a negative power with one of our answers, we have to make sure that it's shown as a positive power or positive index. Okay. So the first one here, there are different ways that we can tackle this question for A to simplify this. What I'm going to do, how am I going to approach it? So I'm first going to focus on the numbers, simplifying the numbers as much as possible. I might look or get a bit messy, but that's okay. And then afterwards we can simplify the pronumerals and see what we get. So in this case here, I've got 15 and a 3, which I know can be simplified, but I also know that 15 can be simplified with that 10 over here, because we've got a higher common factor of 5. So I'm going to simplify that 3 with that 6. So we know the highest common factor between 3 and 6 is 3. So 3 goes into 3 once, and 3 goes into 6 twice. Now 15 and 10, the highest common factor is 5. 5 goes into 10 twice, and 5 goes into 15 3 times. So we've got a 3 and a 2 on the top, and we've got a 1 and a 2 on the bottom. Now we also know that that 2 and 2 can be simplified even further down. Okay, so this highest common factor between 2 and 2 is 1. So what we have on the top is just 3 times 1, which is just 3. And 1 times 1, which is on the bottom, which is 1. Don't necessarily need to write it. If the bottom numbers disappear or something is there, it makes no difference. We'll just make sure that that 1 doesn't go on the bottom, okay? But on the top, it's definitely a 3. Next, we've got pronumeral, we've got an x squared, so, or x namely, so we've got an x squared on the top, and we've got 2 x's on the bottom. Now let's think about this. X times x, when you multiply the denominators, this will turn into an x squared. So x squared divided by x squared divided by x squared, this just is 1. So this is being multiplied by 1 on the top, which is just 3, so it's still going to stay 3. The x's just technically cancel out. And what we're left with is a y, 1 y on the top, and 2 y's at the bottom. So this is y to the power 1. Now, when we are doing a division, we are subtracting the powers if the base is the same, base being the y. So y, power of 1, there's a power of 1 on the bottom, so we're going to take away 1. And there's also another y on the bottom, so we're going to take away another 1. This is y to the power of negative 1. Okay. So all this jargon here just simplifies down to 3y negative 1, but that's not there. We want this as positive into these as a positive indice. So 3 over y1, which is just 3 over y. So whenever I see a 3 over y, I'm going to replace this. I'll put the letter A. Okay. Now, I'm not going to solve for all of this. I'm just going to do a handful of examples. The second one here, how we approach this is a division. Okay. And with our division of fractions, we have to apply the keep, change, flip rule. We're going to keep the first fraction, we're going to change the division into a multiplication, and we're going to flip the second fraction. So what this ends up being is 21x squared over 3y multiplied by x over 7y. You would then use the skills that we just learned within that first question, or you should have learned it within class anyways, to simplify this down, and whatever this answer becomes, you're going to put the letter I for it. The second worksheet, where we're trying to find the first song launched on MTV in 1981. This one is not as intense. There's only there's no fractions involved, but there are negative powers. Okay, so you might get fractions answers with some of them. In fact, all of them, I'm pretty sure. I'm looking at the answer sheet now. All of them have fractioned answers. What we do have to be careful of is how we apply a negative power to numbers that have brackets or no brackets. And the only one that does have brackets, this is D. Okay, I'm going to show you the comparison between A and D. So this is 4x to the power of -1. Now that 4 has no association with that -1 power. So we just leave it as is. Okay, there's no brackets involved with this one. But that x to the power of -1, we've got to remember that x to the power of -1 is also the same as 1 over x to the power of -1, or to the power of 1, +1, sorry, which is just 1 over x. So this is just going to be 4 over x. Okay, that x to the power of -1 just drops to the bottom, and the negative disappears when you put it onto the bottom. If you put it back onto the top, it reappears again. So this is two different ways that we can write this. But we want to express this with a positive power, so 4 over x is our solution. So wherever we see a 4 over x, we're going to replace this or put the letter A. There's one there. I think there's one over there. I don't know if there are any other ones. My aim is to not try to answer this. My aim is to show you how to approach these questions. Second one, we've got now 4 x's inside the brackets to the power of -1. Now we can say that number 4 does have an association with the -1. So this is 4 to the power of -1 multiplied with x to the power of -1. Now again, we just want to put this as positive powers. So this is just 1 over 4 x. Now, whenever you see this in brackets or terms in brackets, you can jump straight from this step all the way to this step here. Okay, you don't have to write this in between step. I just wanted to show you what's going on, how that -1 is having an association with everything in there. Okay, but after a while, you get the hang of it, and you can just jump straight from this to this, assuming that everything is within the bracket. So wherever we see a 1 over 4x, we're going to put the letter D for this. The last example I wanted to show you comes from, oh, I thought I had it there. No, it is not there. The last one I wanted to show you was example L. Example L, I'll just put it here. This is m to the power 6, q to the power -5. GQ. There we go. Let's try that. -5. So you can see that applying the same logic we did with the first one, any positive powered numbers or variables stay on the top. Any negatives go on the bottom. And just be careful. When you apply this logic where you're putting it onto the bottom, what I do see, and this is the incorrect way, what I do see is some students do this, and then they put it onto the bottom, and they put that negative there with it. This is implying something different, okay? These here are just two different ways, two different correct ways of writing it. One with negative powers and one with positive powers, okay? This is implying something different, so just be careful of this, okay? So, m to the power 6 over q to the power 5 has the letter L. The last example here, to do with the Willy Wonka and the Chocolate Factory and trying to find the band name, we are looking at fraction powers. The only thing that's different about this is that the bases are numbers, so we are going to try to solve for this. We want a numerical answer with no powers there within the answer, okay? Because there's no variables involved. They're all numbers. They're all numerical values that can be obtained. Now, with the first one, 81 to the power of a quarter, we've just got to remember the rules that we've learned within the class. That any variable that's to the power of half can be written as the square root of that base. Okay, this is the technical format. The traditional format is this. Okay, it's implied that there is a 2 there. This is just saying what two numbers, when multiplied together that are the same, will give me x. When that denominator changes to a 3 or 4 or 5 or whatever number, this becomes that root of the number. So in other words, this is a cube root. What 3 numbers when multiplied together will give me x. So in this example here, this is going to imply the 4th root of 81. 4th root of 81. In other words, what 4 numbers when multiplied together will give me 81. Now, this is not obvious. Okay, when we get to 4th roots, it's not obvious. You can brute force it, you can trial and error it. I know this number to be 3 because I've worked with cube roots and 4th roots and 5th roots quite a bit. 3 times 3 is 9, times 3 is 27, times 3 is 81. So our solution for this is 3. So wherever we see a 3, we're going to replace it, or put, I keep saying replace, it's annoying me, we put the letter A. Now there is another way that we can tackle this, okay? And this is just knowing that 81 is considered a square number, okay? So if you're really struggling, if you're looking at this and you're like, look, I have no idea what to do with this, why don't we change? This is an alternative method, and this is confusing. Don't do it. But I know 81 can also be written as 9 squared. Okay. So what I've done is I've changed 81 to 9 squared. I've manipulated this because I'm now going to apply one of the index laws that any power that's on the outside of the bracket can be multiplied with the power that's associated with the base inside the bracket. So in other words, this is going to be 9 to the power of 2 times a quarter, or a quarter of 2. Okay, so this is 9 to the power of half. And we got to remember that half can also be written as the square root of that number. And I know what the square root of the number 9 is. That's 3. So wait a second, this 3 here is the same as this 3 here. So the cube root of 81 is exactly the same as the square root of 9 because we're getting the same answer. Okay, so there are different methods to apply to this. If you want to make it easier for yourself, because you do recognize that 81 can be written as 9 squared, by all means you can apply this logic. Okay, all I care about at the end of the day is making sure that you get the correct answer no matter what method you use. The last one, we have 4 to the power of negative 5 over 2. Now, there's quite a few things going on with this one. The numerator is not 1 within the power, it's a 5. The second thing is that the power is a negative. So, the very first thing I'm going to do is I'm going to rewrite this as 1 over 4 to the power of 5 over 2. Now, 4 to the power of 5 over 2. What does this imply? What does this mean? Because when we have a numerator of 1, that's simple, okay? But when we have a numerator of 5 or anything that's different to 1, it gets a little bit confusing. Now, this here is implying that we are trying to look for the square root of 4 to the power 5. Okay, we are looking for the square root of 4 to the power 5, and this is all over 1. Getting a bit cramped there. I don't know if you noticed, but I had to pause because there was a garbage truck that went outside and my son went nuts trying to get it. Anyways, so let's get back to train of thought. Alright, so we're left with 1 over square root of 4 to the power of 5. Now this here, we want to simplify. Now, there are 2 ways that we can approach this. Okay, we can work out what 4 to the power of 5 is, and then square root it. Or we can square root 4 first, and then get that answer and put it to the power of 5. I think the second way is easier, because trying to find out what 4 times 4 times 4 times 4 times 4 is without a calculator is actually quite tricky. So we do know what the square root of 4 is. That's 2, because 2 times 2 is equal to 4. So I'm going to write this as 1 over 2, which is the square root of 4, and have that to the power 5. Now this is easier to work out. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So our final solution for this one is 1 over 32. So anywhere we have a 1 over 32, we're going to replace this with the letter L. Okay. There are some trickier questions that are involved with this, like V. V is quite tricky, but you can use a calculator to help you out. Try it without a calculator first, but if you need it, you can use it. That concludes this video, and hopefully this will be the last video for the worksheets. There might be another video tutorial. As far as I'm aware, there is going to be a lockdown that's extended to Tuesday next week, so on the 27th. So I'm making this right now, Tuesday, 11 p.m. on the 20th. Got notifications saying the lockdown is going to be extended till next week. So there might be another video that's to follow this. Till then, see you guys soon.